Hello class, this is section 2.4, Graphs Can Be Misleading. I am your instructor William Bielman and this is Stat 1200. So for this section, this is more of an enrichment section. So I didn't create slides for this, we're just going to use the publisher slides just because we're going to review a few things. This should be a shorter section. So again, this is section 2.4, how graphs can be misleading. We have a couple of objectives: understanding how improper positioning of the vertical scale can be misleading, understand the area principle for constructing statistical graphs, and understand how three-dimensional graphs can be misleading. So what is graphical misrepresentation? Statistical graphs, when used properly, are powerful forms of communication. Unfortunately, when the graphs are improperly used, they can misrepresent the data and lead people to draw incorrect conclusions. We discuss here three of the most common forms of misrepresentation: incorrect scaling on the vertical axis, incorrect sizing of graphical images, and misrepresenting the graph using three dimensions. So first, vertical scaling. So the baseline of a graph or plot is the value at which the horizontal axis intersects the vertical axis. So typically on most graphs, it starts at 0. That's a pretty typical thing, but sometimes people don't use 0, and we can see how that can become very misleading. If we look at the left-hand graph, we see that they're all roughly the same size. The 2006 is maybe around 47, 48, and 2012 is around 52. That's only a 10% difference from 48 to 52. Not that many millions of passengers increased. But when you look at the right-hand graph, all of a sudden 2006 is very small because the baseline is 47. So it looks like maybe 10 times as many passengers traveled in 2012 compared to 2006, but that's not true. Because we have improperly scaled the y-axis here, we see what has happened. So you have to have a good reason for using a non-zero scale on the vertical axis. When in doubt, just use 0 as your vertical scale. You can do the same thing similarly with a time series plot. So this is the exact same data. It's just been moved from a bar graph to a time series plot. And we can see how in the left-hand graph, it's pretty flat, but in the right-hand graph, it looks like it's increasing a lot, when in reality, it's only gone up by about 10%. So you have to be, again, very careful with your scaling. So using the area principle. So the area principle is when you end up drawing two images side by side, but you don't realize what happens when you change the proportions. So we'll see that in the next slide coming up. So here we look at the cost of jet fuel. It has increased from 2003 to 2013 by about 3.5 times. So if I make it 3.5 times as wide and 3.5 times as tall, I have not made this picture of the jet on the right 3.5 times as big as the picture of the jet on the left. I've made it 3.5 squared times as bigger. So it's actually 12 times as big approximately as the jet on the left. So by doing that, by scaling it in both axes, we've actually distorted what we've tried to show by quite a bit. Instead of the jet on the right being 3.5 times as large, it is 12 times as large. So you have to be very careful when you do stuff like this, because these are common mistakes that happen a lot. The final thing is how three-dimensional graphs can be misleading. So here we see a three-dimensional graph. And again, it's the same data from before, where in 2003 it was around 80 cents, and in 2013 it's about 3.5 times as tall. But since the 2013 is closer and in the foreground in this three-dimensional graph, it looks more represented than the 2003 data, so it looks even bigger than 3.5 times. So again, distorting the bars and making 2013 look larger than 3.5 times 2003. So you have to be very careful with how you present graphs, because you can unintentionally skew what you're showing and provide a message that you didn't intend. Things you should now understand are the 3 ways graphs are typically misleading: incorrect positioning of the vertical axis, incorrect sizing because of the area principle, you're actually making it much bigger than you think you are. And then the third one, how by changing the perspective and making it 3-dimensional, you are misrepresenting what is actually there. And this is a very common mistake for non-statistical people to do, because they're trying to show, oh, look at how much this has changed, but they don't realize they're actually distorting it even more and making it look like it changed more than it really did.